close till I get up. Time is barely on our side. I don't wanna waste what's left. The storms we chase are leading us, and love is all we'll ever trust. Yeah, no, I don't wanna waste what's left. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways, and on we'll go.
So, for our introduction, taking good care of pets takes a lot of responsibilities. This includes keeping them safe, showing concern, and feeding them on the right time. Because we all know some pet owners didn't have enough time sometimes for them to feed their pets. Some pet feeders requires manually setting up their timer for it to release the food once per day. So it is not enough for a busy pet owner. That's why we came up with this project, the Arduino-based automatic pet feeder. It's a mobile-controlled feeder in which owners have the capability to feed their pets on time, even if they are far away from home or working on their jobs. By using this, the owners don't need to manually feed them every time, and does not need to think about them if they are hungry. They can feed their animal's companion and focus on their work at the same time. Next, for our statement of the problem, the general question we formulated is, how can the pet owners ensure that the pets will really get to eat on time and keep track on their diet, even within being out of the area? For our specific problem, first, how to develop an Arduino-based automatic pet feeder. Next, how to develop a system that will ensure that the pets will be fed on time even if the owner is away. How to develop system will help in maintaining good weight management of pets. Next, the conceptual framework. Shows the conceptual design framework wherein the input, the proponents elaborated the requirements that are significantly represented to the development of the study, such as information gathered, related literature and studies, existing process, knowledge, software, and hardware requirements. The knowledge in programming is needed because the system will only work in a correct programming algorithm. The Arduino IDE's software will be used to make the algorithm much more efficient to the design. The hardware requirements are the device that the proponents are going to use for the development of the feeder. The following are the serving motor is connected to the system in which it will be the one responsible to the rotation of serving food. RTC, or the real-time clock module, will be used for the set of the time scheduled feeding. Connecting wires for the connection of dispenser and the Arduino. Food dispenser will serve as a storage for the pet food, and Arduino will be used to have communication between the software and the hardware. Next, the process will be encountered by the proponents or the process development and testing development. In process development, the researchers will start flowcharting and coding the system, designing of the prototype, and building the whole automatic pet feeder. In testing development, the proponents will test and examine the prototype and identify other lack and technical problems. The last stage, which is system implementation. The proponents already have fixed the troubleshooting and other technical problems, in which the completion of automatic pet feeder. With that, we came up with the objectives of the study. The general objective of this study is to develop an automatic feeding machine using the Internet of Things or IoT that will help the owners in terms of pet feeding. It will create an automatic hardware to feed pets, which will be the output for the product. And it will develop an app that will be used to exact the time of feeding and to run the machine and gives the owner chance to feed pets while away. And it will also provide owners advanced and personalized way of keeping pets using the developed app and systems.
For the scope and delimitation of the study, the scope will have the following. The study will focus on constructing an automatic pet feeder and create a mobile application for controlling and monitoring the feeder. Next is, the mobile application will use IoT or Internet of Things to connect Arduino and the application. And lastly, the proposed study will feed the pets at a given set of time with the correct amount of food depending on their diet. And for the delimitation, the prototype is medium in size, which can hold dry pet food only. And the prototype can be scheduled and served food 3 times a day, and that is for breakfast, lunch, and the dinner of the pet. Next, the application is compatible for both Android and iOS devices. And lastly, the feeder is for small to medium-sized pets only, and that is specifically cats and dogs. Next is the significance of the study. The following will be those who will benefit from this study. And first up are the pet owners. The pet owners won't have to worry about their pets anymore whenever they are away from their home. And they will have a less loaded schedule because they won't have to worry about the pet feeding schedule anymore. Next is the pets. The pets won't have an issue regardless with being overweight or overfed because with the help of pet feeder, the food will only be provided at the set time. And lastly, the future researchers. Mostly, this topic is about technology and Internet of Things. And we know that technology is rapidly evolving. This topic may be expanded within the next generation. And for our research design, the methods of our research are quantitative and a descriptive type of research. And for our system making, we used a waterfall model.
So let's talk about respondents of the study and sample technique. So in getting sample size needed for our data collection, we use stratified random sampling as a sampling technique. With that, the researchers used solvent formula to compute the total number of respondents that we needed. The sample size that we needed to achieve was 249 respondents. We conduct survey amongst senior high school students as a form of data collection. Research instrument. The researchers use Likert scale method on their survey questionnaire. It is where the respondents can choose if they strongly agree, agreed, disagreed, or strongly disagree to each questions provided in the questionnaire. The researchers also conduct a survey amongst senior high school students as a form of data collection, and for the researchers to know if they approve the automatic pet feeder for their pets.
In the flowchart, the flow of the program and system will start off with the need of it to be accessed and controlled. So, to start it, first, the admin or the pet owner shall access the system hardware, which is the pet feeder. And for that, the admin will use an application software to send and request the hardware system that is connected to, wherein once accessed, the hardware shall now start and be able for controlling. Next is the use of application. For that, the admin shall select the created setting for the feeder, and then the admin shall proceed to the next step, that is to input the time for the feeder to activate. And the system shall read the input and process it with a yes or no. And once the goal is achieved, the servo motor will be activated and the food shall drop at designated time set by the admin.
Next, we have the system development. The mobile-controlled Arduino-based automatic pet feeder is a pet feeding system that is powered by an Arduino and ESP8266 Node MCU or a Wi-Fi module. Mobile application is used for controlling and setting the timer of the feeder, so that even if the owners are away, the feeder will still produce food for the pets at the desired time schedule. Aside from the system, the feeder is made up of recycled materials such as the cardboard box, used cans, and used papers. So the method that we are going to use for the system making is the waterfall model. First, we have the requirement analysis. In this phase, the researchers collected necessary data from different sources like related literature, studies, and the internet to help in conceptualizing the prototype and the system. The researchers also gathered information on what were the needs of the system in terms of hardware and software making. In the system design phase, the researchers started planning the overall design of the system from its algorithm, functions, and the prototype design. As part of the planning stage, the size of the prototype, the interface, and the color. Also, this is where the proponent starts to specify the hardware requirements they needed, such as the Arduino Uno, servo motor, Wi-Fi module, connecting wires, USB cable, and the power source. In the implementation phase, the researchers started the development of the hardware. This includes the circuit and the prototype design. Also, the development of the mobile application that would serve as the controller of the system. Arduino IDE and C++ programming language were used for the coding of the algorithm and that control the function of it. In the testing phase, the researchers started to test and evaluate the prototype to know if it meets the project requirements. During this step, the prototype can now be able to serve food for the pets as well as set a mealtime schedule for them. This would be tested and evaluated in terms of its accessibility and reliability. When the testing is done, the prototype will be deployed in the customer environment and be evaluated. In the maintenance phase, all the problems encountered during the prototype testing and evaluations are being fixed for better improvements and results. Here are the softwares that we use in programming our system. First, we have the Arduino IDE or the Arduino Integrated Development Environment, which is a cross-platform software that is written in functions from C and C++ programming language. It is used to write and upload programs to Arduino and other compatible boards. Next, we have the Blink IoT platform. It is what we used in making our mobile application or the controller of the system. Blink is a new platform that allows you to quickly build interfaces for controlling and monitoring your hardware projects from your iOS and Android devices. With this, you can create a project dashboard, arrange buttons, sliders, graphs, and other widgets onto the screen. So you can activate the usage or the connection of the Blink and the hardware by coding it also to the Arduino IDE. Next, we have the system block diagram of the mobile-controlled Arduino-based pet feeder. In this figure, it shows how the system works. First, with the use of the mobile application, the user will set a command for the feeder, either a time for the pet's eating schedule or manual feeding. Next, the command will pass through the Wi-Fi module, which is the Node MCU that is connected to the microcontroller Arduino Uno, which will be the one that will send the data through the servo motor, the one responsible for the exitway of the pet food. When the servo motor rotated, the lid that blocks the exitway of the food will open, allowing the food to drop for your pet. Next, we have the system layout. In this figure, it shows the system layout of the automatic pet feeder. The system would start by powering up the Arduino Uno and the Node MCU using a power adapter which will be plugged to an outlet. When the microcontroller and the Wi-Fi module is accessible and ready, the the user can now send commands through the mobile application. Since the servo motor is attached to the lid that blocks the food, when the servo motor receives the command, it will rotate 45 degrees along with the lid to open the passage or the exit way of the pet food. When the exit way is now open, the food will immediately drop into the food bowl. Mobile application layout. So, as stated a while ago, Blink was used for developing the mobile application of the automatic pet feeder, which serve as the controller or the remote of the system. It is where the owner can give their pet snack or full meal. The admin can also set a time schedule 3 times a day for their pet's meal. So here are some of the screenshots of our mobile application. So aside from the system development, we also need to get the results from the survey that we've conducted. If the pet feeder is efficient, reliable, and accessible for their pets and for the pet owners. But due to the certain reasons, the desired number of respondents wasn't met. So the desired number of respondents we have is the 249. Since it is both grade 11 and grade 12, only 157 participated or answered our survey. But we still managed to get the results for the survey that we've conducted. So as you can see in our bar graph, 42% of the respondents agreed that the automatic pet feeder will be reliable, accessible, and user-friendly for them and their pets. While 24% strongly agreed. For disagree, we also have 24%, and only 10% strongly disagreed to the efficiency of the feeder. To sum it all up, the mobile-controlled Arduino-based pet feeder would be a big help not only to a pet owner, but also businesses and organizations that takes good care of pets. This system is accessible to Android and iOS mobile devices. Therefore, the user would not need to look through the insides personally. The user can set certain time schedule for the pets and can manually feed their pets anytime they want. Also, according to the survey conducted, student pet owners had agreed that the automatic feeder is reliable, user-friendly, and helpful for them and for their pets. After all the studies, researches, and the developments, the researchers conclude that the mobile-controlled Arduino-based pet feeder is effective and efficient in terms of regular pet feeding and being a pet and owner-friendly. The project met the objectives stated previously and concludes the following. The proponents created an Arduino-based prototype to feed their pets. A mobile application was also created to control the whole setup of the pet feeder. The owners can set a mealtime schedule for their pets 3 times a day for breakfast, lunch, and dinner. The pet feeder is accessible, easy to use, and effectively functioning. That ends our video presentation. Thank you for listening.